Welcome to Learning with UNP. In this session of Business Intelligence with Power BI, we will explore two essential concepts in database management: primary key and foreign key. These keys play a foundational role in organizing, structuring, and connecting data within and across tables. We will use Maven Market Dataset for this demonstration. We have imported all the required tables and also made required changes. Let's start with the primary key. A primary key is a unique identifier for each record in a table. Think of it like a unique ID card that ensures each row can be uniquely identified. Every primary key value is unique, which means no two rows in the table can share the same primary key value. It is also never empty or null. Every record must have a valid primary key value. Let me tell you the characteristics of a primary key. Uniqueness. Primary key ensures no duplicate values for this column. Not null. Every row must have a value in the primary key column. Single column or composite. While it's common to use a single column as a primary key, you can also use multiple columns together as a composite primary key. In this case, the combination of columns must be unique. Here, there can be a question like this: can a table have two primary keys? Well, the answer is, in relational databases, a table can indeed have two unique identifiers, but it technically doesn't have two primary keys. Instead, we can use composite primary keys, where two or more columns together uniquely identify each row. However, if a table needs to have more than one unique identifier independently, then unique constraints or alternate keys are applied rather than using multiple primary keys. Thus, while a table can use multiple columns to uniquely identify records, the database allows for only one primary key constraint per table. Next, let's look at the foreign key. A foreign key is used to link records between two tables, creating a relationship. It is a column or set of columns in one table that refers to the primary key of another table. This relationship lets us connect related information in separate tables without repeating data. Let me tell you the characteristics of a foreign key. Linking tables. The foreign key points to the primary key in another table, linking rows between tables. It can be null. Unlike the primary key, foreign key values can be null if a relationship is not required for every record. Referential integrity. This key helps maintain data consistency by ensuring that relationship is valid. For instance, only allowing IDs in one table that actually exist in the linked table. Here, there can be another question. How do we identify a primary key and a foreign key? In order to identify a primary key, look for columns that uniquely identifies each row and are marked as required. In order to identify a foreign key, look for columns that reference the primary key of another table. Over here, you all can have one more question. How many primary and foreign keys can a table have? A table can only have one primary key constraint, ensuring a unique way to identify each row. However, you can use multiple columns together to create a composite primary key if needed. And a table can have multiple foreign keys. Each foreign key links to a different table, allowing you to create multiple relationships between tables. Now, we will move into a practical example using the Maven Market Dataset. This dataset includes multiple tables that contain information about Maven Market's operations. We will examine each table to identify the primary and foreign keys. Let's begin with the Maven Market Customers table. Here are the columns in Maven Market Customers table, starting with customer ID, customer account number, first name, last name, customer address, customer city, and age at the end. In here, the customer ID column uniquely identifies each customer in the table. It's specific to each individual. It does not allow duplicates, and it serves as a unique identifier, making it an ideal primary key for this table. This table primarily focuses on customer data, so it does not contain any direct foreign keys. However, customer ID may serve as a foreign key in another tables, like transaction table, to link customer data across tables. Moving on to Maven Market Products table. The columns here are product ID, product brand, product name, and low fat at the end. In here, product ID is a unique identifier for each product. It's specific to each item in the product catalog, making it the primary key for this table. Like the customer table, this table does not directly contain any foreign keys. However, product ID will serve as a foreign key in tables like transactions and returns to connect product information with transactions and return records. Next, let's move on to Maven Market Regions table. In here, the columns are region ID, sales district, and sales region. Over here, region ID is the unique identifier for each sales region. This makes it the primary key for this regions table. Region ID may be used as a foreign key in the stores table to associate each store with a specific sales region. Now, in the Maven Market Returns table, the columns are return date, product ID, store ID, and quantity. This table may not have a single column primary key because records could involve multiple returns of the same product at different stores on different dates. A composite key comprising return date, product ID, and store ID can serve as the unique identifier for each return entry. The foreign keys in this table are product ID, it links to product ID in the products table, store ID, which links to the store ID in the stores table. These foreign keys connect return records to specific products and stores. Let's look at the Maven Market Stores table. The columns are store ID, region ID, store type, store name, and grocery square feet at the end. Over here, store ID uniquely identifies each store in the dataset, making it the primary key. The foreign key here is region ID. It links to the region ID in the regions table. The foreign key region ID allows each store to be associated with a sales region. Finally, let's look at the Maven Market Transactions table. The columns here are transaction date, stock date, product ID, customer ID, store ID, and quantity. This table may use a composite primary key consisting of transaction date, product ID, customer ID, and store ID to uniquely identify each transaction record. The foreign keys are product ID, which links to the product ID in products table, customer ID, which links to customer ID in the customer table, store ID, which links to store ID in the stores table. These foreign keys link each transaction record to specific product, customers, and stores, establishing relationships across tables. Finally, by identifying primary and foreign keys in each table, we could build a relational structure within the Maven Market Dataset, enabling us to effectively retrieve and analyze data in Power BI. This understanding is crucial for creating meaningful insights and maintaining data consistency across tables. This is all about today's lecture. See you in the next lecture. Thank you.